Okay, so hello everyone. Today we are moving to another part of the AI class. So as you remember, we were like closing the first part, let me say, of all basic statistical computation, probabilities, and like typical AI problems like search problems and gaming. Now we are going to move to, let me call it, a more advanced level, which is coming next even in the history of AI, which is a subfield of AI. In particular, now I'm talking about machine learning. But before discussing details about machine learning, let's consider learning like machine learning, deep learning, reinforcement learning in the same set, which is the set of learning. So the evolution now is coming from like probabilities, from statistical values that we are counting given a limited search space towards learning. And what does learning means for you? What comes to your brain when we talk about learning? Information. So you are right. Last time we were already discussing about information. What comes before information that we discussed last time? Data. So last time we were saying that the world is full of data. And when I'm saying data, I was taking the example of this element. I'm almost taking the same example. So if you just close your eyes and open, you see this. It's something, okay? It's black, it has some shape, it has some characteristics. So this is just data. This is a chair. Now you are knowing what is this data. So you have additional information. This is a black chair. This is a comfortable one. So this is now from data to information. And then from information, what we want. We don't want, not only don't want to recognize things or to know things, we want to make it useful, this information. So how to make it useful? Is that what we already said, that to take decision. Okay, so it's all about turning data into information and information into insights. And insights are what are going to drive this world. It's driven by decision taken, thanks, for example, to AI, to humans, and this is what we want. We don't want just to have information. It's everywhere now. Search like engines, for example, Google, even the GPT now, learning is there. Information is everywhere, like we say. But the way you learn, the way you profit from that information, it's not only that you are reading and going through information. No, it's how you apply that, how we can see the difference, what changes it brings to the table. Okay, so I want, for example, to see if you know something, it's impacting your behavior, for example. And what we want is to make, for example, better environment, better humans to go forward. Okay, so this is just an introduction to the topic, and now we are going to dive in details. So I am aware that some of you are already getting the machine learning class. So we are going to have like discussion. I know the AI class was a little bit hard for you to follow and all, but this would make it like we take some rest. For those who are exploring machine learning for the first time, it will be fun. So don't worry. And I would like really to exchange ideas, to discuss. If you have any knowledge, never hesitate to share with everyone, okay? So what we will do today is that what we are going to start from what we already seen so far. So far, we studied like in the introduction to AI, what we've seen. We've seen the search problems, for example. And in search problem in particular, we went through different search algorithms. We went, for example, we've seen the DFS, the BFS, the A star, or whatever. All this, the main objective was what? It was to solve a search problem, given a search, like a space, a search space, okay? So what difference between one algorithm and the other one? The difference was in terms of performance. And to evaluate the performance, we were seeing some metrics, like, for example, the complexity of the algorithm, the space complexity, the time complexity, and so on, okay? Now, how to decide which is the best algorithm now? It's better on this performance. And what we are looking for, and everyone is looking for, is the best algo, because I won't waste my time using all algorithms to like say which one. So we know that each algorithm is good for a given like problem, but what we are looking for is the optimal solution, whatever the algorithm, okay? So we want, for example, to reach from the initial state to the goal, to go through the shortest path, let's say. In other scenario, we want to have the least cost, okay? So these are examples of search problems. In more like advanced steps, before the Bayesian networks over time, let's discuss the Bayesian networks. At this level, what we were focusing on, we focused on uncertainty. Means if I have, we were discussing last time about random variables. So if I have a set of variables and there is dependencies between the variables, which what we were discussing is the conditional probabilities, for example. So some like facts is due to some probable other facts. It could be this or that or another possibility. So it's a huge space. Still, we were able to model that. Still, we were able to like make inferences based on that. And this is all thanks to the probabilities computation, because each time we had different mathematical expression, but at the end, what we did was all about probability computing, okay? So starting from this is the foundation, okay? If you are good at probabilities, you are good at mathematics, now you are already good with the AI class. What will happen is that while we are moving towards learning methods, and why you are maybe next getting special classes for machine learning, maybe you may dive deeper into deep learning, for example, because these like kind of subfields, let me call them, of AI, they are there to address larger space, because you cannot keep checking all the possibilities. You cannot like keep mentioning all possible random variables, trying to make connections. The space is going to be that much huge, and how many resources you are going to use, how many probability values you are going to use, how many theorems you are going to apply. So this is a serious problem, and which is reflecting the real world problems, okay? So in this case, exhaustive models, they are not enough, and this is what we already seen, okay? So what we need is, it's not enough to use the fixed probabilities, it's not enough to keep doing this. What we need sometimes, or at some given points, is to use data, to profit from this available information, let me say data, okay? To make, for example, predictions, or to explore patterns, for example. So the key idea here is to learn from examples. And whenever we are talking about deep learning, let me say, I always say it's like having a new baby. Your model or your algorithm is a newborn baby, okay? So as a baby or as a human, how we learn? I keep seeing this world. Okay, we cry at first, but at the end, I keep checking things. After that, I keep learning, seeing like something many times would help me learn what is that, or it's going to put me in some conscious level that I will be aware if there is that thing straight. I'll say that's a chair. I would sit or not. So this is what a human does. So AI is going to perform, we are trying to make it act like human, okay? So at this level, we want to profit from the existing amount of data rather than explicitly coding rules or probabilities, okay? Because what we did before is we were like, it's all about computation, okay? We were finding the probabilities. We are like hard coding, I would say, like saying, if this will happen, then I will go on this path. If I'm in this path, then this is, because of this probability, I'm going here. So it's all based on such algorithms. So this is what we like statistical. When we talk about statistics, you know that it brings to the table probabilities and many mathematical background. So statistical learning now, it's a very important point, what we are going to just go through today before like introducing machine learning, because you need to have this mapping between statistics and machine learning. For the statistical learning, which comes in the middle now, it's a process, or it's a way to focus on making predictions. And if you are going to say, now we are going to change the words. Before we were talking about inference, okay? So inference or predictions, what we are going to to use now, we are going to use the word prediction more than inference from the existing data, using or exploring the relationship between the different input variables, or let me call them the features. We are going to focus with this later, and the output variables, which are the targets. So don't worry if you're not understanding some keywords, we'll cover that. Now, how it's going to be, this is using the probability theory that we were discussing so far, as well as the statistical inference in order to estimate the unknown relationship between variables. Now, from this, we go to machine learning. Between machine learning and like statistical learning, there is no gap. There is that intersection that makes machine learning at some point be seen as a statistical learning method, okay? So the machine learning here, it's a broader field that already includes the statistical learning, but it also covers like larger applications. It includes, for example, the methods coming from computer science. So if you focus with statistical learning, if you have that method, like let's take the example of Cole here with us. So Cole is coming with a mathematical background. Let's take the example of Farah, for example, in-person students. She's coming from a computer science background. So machine learning, it's where mathematicians and like computer scientists meet, okay? And they're already sitting on the same table. I'm so happy to see this. So there are many examples of machine learning algorithms. Some of them you may know, some of them we are going to explore, and let's not focus on that for now. Let's come back to the first introductory class when we were introducing AI and things like subfields of AI, machine learning and deep learning. So when we talk about AI, we said it's like about programming things. I have a set of rules. And here maybe there is something called, I'm not sure if you get this class or not, what was that? Prolog. It's like a programming language, same as MATLAB or Python. So this is a programming language which is designed to program rules. If this, then this. And so this is a really strong, and I remember I had a class especially about this. It's called declarative programming, okay? So each point in AI could be taught even as a separate module, okay? But let's try to put everything together, like to see the bigger image, okay? So if already now AI, it's about programming things, preparing a program that is a little bit similar to a human, and we will call it that an agent, an intelligent agent, where the agent is having the ability to sense, to reason, to act and adapt, okay? If all this is there, so there is an AI system. Next now, subfield of AI is the machine learning. And in machine learning, we are not programming, we're programming algorithms. And you know, an algorithm is like how to make, for example, an omelette. I don't know, I bring 3 eggs, then I put some salt, then I put some black pepper, and then I mix everything together, then I switch on. So saying this, that, then 1, 2, 3, this order is an algorithm. So everyone here must not say that I hate algorithms. I hate to write an algorithm, because our daily life, it's an algorithm. So every day we wake up in the morning, I don't know, I do my morning routine, I do some stuff specific based on that day, I come to the office, I prepare this, I do that. So this is the algorithm, okay? Are the steps that we are taking, okay? Now, this algorithm is not just about different known steps in machine learning. We say that we are introducing the word learning, which is bringing to the table data. So this algorithm is going to perform in order to improve the more that it is exposed to data over time, okay? And in life, it's the same. The more we see things, the more we learn. So this is the machine learning algorithm. The more you are going to feed data, the more this algorithm is going to learn, okay? Then a subfield is deep learning, and here the difference is, let me say, in coding, because there you are coding the algorithm, you are writing the steps, but in deep learning there is like a set of architectures, and these architectures are designed specially to look like, let me say, human, to mimic the way a human brain, for example, is designed, or human neurons like function. And these algorithms are made to extract features and to learn from that features. Okay, so you see how the evolution is from AI to machine learning and then to deep learning. Okay, I'm going to stop here. Okay, now what will happen is that we are going to start with the definition of machine learning, which everyone with the AI like master, for example, must know what is machine learning. It's not like you are the expert of all the algorithms. You are able to do like SVM, you are able to play with the neural networks. And when I ask you what is machine learning, you cannot discuss. Because there is a culture, and this course is based on discussion. So you must have that knowledge. If you are sitting even with people that do not anything about machine learning, you must have that ability to convince them, to teach them, to tell them in simple words, because to understand something, you must not complicate it with lots of maths, lots of expressions, also make it simple. What is machine learning? So I will ask you this question later. But before that, we are going to go through a set of definitions that I'm selecting, I'm liking. So because I find it's illustrative, otherwise everyone today is giving like machine learning algorithm. And after machine learning class, you will also have your own definition, which would be like at some given points similar, okay, which makes sense. So and I have a problem with pronouncing names. Who don't have this problem? Who is this?
Dr. Samuel.
Okay, so it's Mr. Samuel. Let's say keep it like that. So in 1955, he's coming with a machine learning definition that's saying it is a field of study that gives computers the ability to learn without being explicitly programmed, which is now making a transition between AI when we are giving an explicit like set of rules to the computer. Now it's going to just break this typical way of leading or programming computers to say that the computer now is not anywhere explicitly like programmed, somehow implicit way. There is an implicit way that computers are going to learn, and for sure from data. So this is a very basic, showing the transition from AI to ML. Another definition that I love from Herbert. So this is like, this person was winning the Turing Award in 1975 and the Nobel Prize in Economics in 1978. So here I find it more like real. We are approaching to what is machine learning. So it is like he's saying that it's learning is any process by which a system improves performance over experience, which makes sense. Here we are at the level of defining what is learning, because in machine learning, the word machine is clear for everyone. Now the learning part, it's a process, and this process is going for what? For which reason? For improving the performance while exposed to more data, which is the definition that we started from. So machine learning is concerned with computers programs that automatically improve their performance through experience. So there is the word experience, the word data, there is the word performance. So all this is mandatory to have an accurate definition. The last definition that is really like final one, which is by Mr. Tom in 1997. So a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. So which shows the same thing but with an example. And what we love is we give an abstract idea, let's illustrate it with example. So this is an example that I was preparing for you. So we have a set of like symbols, for example, T for task, P for performance measure, and E for experience, okay? Now, 3 examples. The first one, our task is playing checkers, for example. What is the performance measure in this case? It is the percentage of games won against an arbitrary opponent, okay? And what is the experience here? It's the more you play and practice, the more that you have chances to win, okay? Next, we have the example of the task of recognizing handwritten word, and we are going to perform such tasks given the data set that we would see later, which is the MNIST data set. So how to evaluate this? A performance metric here is the percentage of words correctly classified. So if I will give you a set of words, you are correctly classifying all of them, so your score or performance is 100%. And the database of human labeled images of handwritten words is the experience that you are going to have. It's what we will see later, we'll call training data, okay? I will start throwing some words to find you like later ready for that. Another one, it's the case of, or the task of driving on 4-lane highway using vision sensors. In this case, our performance metric is the average distance traveled before a human judged error. And our experience is a sequence of images and steering commands recorded while observing a human driver, okay? So I think it's making it more clear, and the experience in this case, it's shown like data that we're going to have. We have training data, and then there is a task given that data. That task is after that evaluated, given like the behavior or that is shown at each example, and the performance is, let's say, the true, like how many true positives I have, for example. Okay, we will see many performance measures, but let's make it simple for now. Okay, so for online students, is that clear?
Yeah, that makes sense. I have a quick question about like, what about a machine learning algorithm that it faces more data, but it gets worse with time? Because none of these definitions like take that into account if it gets worse.
Yeah, so Zoya, these definitions of machine learning we are studying now, this is the recent one. It's 1997. But if we come back in time, this one is 1959. So you can imagine if I am going to say huge data. I know what means huge data today, but huge data in 1959, it's a joke for today. So we need to be like aware of the context of the definition, because when this definition of ML that we are going to start from, that they are the basic like block were there was a given setting, a given space. So we need to respect that. Next, we are sure that there is this problem. The space is getting like moving on higher dimensions, and this why the deep learning is coming. And then deep learning is not enough. Within deep learning, there is just GPU training, and there is like we are using more resources. You understand that? And optimization techniques are also like really evolved. So what we will say for now, these basic like definitions for the experience which is large, today we will consider, okay, to be clear and honest, it's larger than the context that we were studying for search problems, because at the end, the space is still limited. At that time, I was saying it's huge space, but if I would see it with the computational like abilities that we have today, it's limited. It's not enough for the space which is more large. So let me say more large, now it's the machine learning. Extremely large, we are going to check for the deep learning. So it's like small, medium, large, and XL. Let's treat it like that. We are just moving from the S to the medium or large, okay? So this is a machine learning. Is that clear, Zoya?
That makes sense, and I really like that analogy.
Okay. So we are going through these definitions. Any questions from other students online? Okay, in person? Okay, so machine learning now is programming computers to optimize performance criterion using example data or past experience. So this is clear for now, right? No, it's not clear, because to optimize itself, it's a huge field. I can say it's still unclear for me, because the more you read about optimization techniques, the more you will recognize that you don't know anything about optimization, okay? But to make it simple now, let's think of a problem And if we are having a problem, we can for sure have a visual representation for that. Okay, let's suppose that any problem that we are having, whether it is represented by, we always have the time factor. I'll always present things in the 2D space, okay? So where I have my time, and through time, my performance. And at some points, when we talk about the performance, it's like we are, how much could be the best you can give in the exam? 110, my class, but it's usually 100, okay? So it's 100. So your effort for everything in this life is 100. This is coming from probability. So it's always 100%, which is 1. The sum of your all efforts cannot be more than 1, okay? But your girlfriends want it to be 200% most of the time. So now, if I'm talking about, this is not clear. So now if I'm talking about performance, I am saying given a score or max score, which is 100. If I'm saying 100 is coming from where? It's coming from number 1, which is the maximum probability that could ever be, okay? Now, if I am going to decide, and we were already now exposed to the fuzzy logics thanks to Zoya. Now, who is taking the exam? I think no one. Yeah, I'm sure that last day, last minute, last second, I will receive many emails that, oh, the time I will, okay, let's discuss that later. But let's suppose that I took the exam. I didn't got 100%. How much I could get? For example, 90%. Okay, let's say that. I must have like a mistake in the A-star algorithm exam. So 90%. Now, to measure my performance in the exam, is this a complete information given the fuzzy logics? I succeeded with 100, with 90% percentage. This is the success. But
I failed with 10%.
Always brilliant students don't say that I got 90%. I lost 10 points, for example. You got it. So we don't always look to the half of the cup which is full. Like Zoya was teaching us, we can see the empty face, for example. Okay, so there is 10% which is failure. So for both now, these are the metric, the final metric of my performance. It's not only that the success. So because to get that 100, there is a percentage for success, a percentage for failure. So the percentage for failure in machine learning or deep learning, we are going to call that error. Okay? Okay. Okay. The biggest error that could face you. So now, if we want to evaluate the performance now, I don't know why the people who are doing machine learning, they don't want to focus on success criteria, they focus on failure. It's complementary like performance. But now, whenever we are going to talk about the evaluation, we are going to represent the curve of the error, okay? So if I want to represent any given curve, what are possible like representations that I may have? Whether I would have a line, means it's a stable error that I'm going to make during my life, let's say, or for a given problem. Okay, I want to make a general. But it could forever stay like stable? No. So sometimes there are ups, there are downs, okay, there are many problems. So, but let's zoom on, for example, a representation like this, where the problem is what we call is convex. Okay, so what we will have here, the curve, it's having, there is a direction, okay? The curve is first, the error is first decreasing. So supposing that I'm first time taking the review exam, maybe I am having 100% error. I'm not revising anything, which is very normal. Then I'm trying to get some help. Then the error is decreasing. Now, the day of the exam, everyone is going to do his best. So we are supposed to be at the optimal solution. After 10 years, if I will give you the same exam, you will again have 100% like error, which makes sense. Okay? So this is an example. So whatever I always represent with a continuous line is really a set of discrete points. Okay, so given now this problem, which is my optimal solution? Where it's when my error is minimum. And all machine learning, deep learning about optimizing the solution for finding the best algorithm, let's say. Okay, so this is an example of optimization. I wish now I'm making it a little bit clear for you. Okay, it's clear for everyone? Great. Now we are understanding machine learning is programming computers to optimize a performance criterion. The criterion could be like illustrated here, the error, for example, using example data or past experience. Okay, now there is a role of statistics here, which is the inference, okay, from a sample, and there is a role brought thanks to the computer scientists, which is the efficient algorithms to solve the optimization problem, representing and evaluating the model for inference. Okay, now let's illustrate things. Okay, machine learning, if we compare it now to the traditional approaches, what is the difference? The traditional approaches, all the time we're having a problem, okay? And all the time we are studying this problem. In the traditional approaches, we are using rules, like I was saying. So each time we're having a problem, we are writing rules. And based on rules, there is an evaluation. The evaluation could take you to the best solution, expected one, let me say. And the evaluation could also give wrong results, let's say. And this would let you analyze the error and again keep studying the problem, updating your set of rules, and it's a loop until finding the best results. This is the typical not machine learning, typical approach, traditional approach. Still, we are not talking about machine learning. So whenever we talk about AI, now you are able to say there is a very old, let me say, typical approach, which is based on rules. Okay? Now, moving to the machine learning, we are introducing or bringing to the table data. And data now is used, not like before, to write rules. No, we are not at this level anymore. So the data is used to train a machine learning algorithm. Now, once my algorithm is trained, I am again going to evaluate if all okay. Otherwise, we keep analyzing the error and learn. Okay? This is the learning process. There is a difference now, which is clear. Now, the key difference that I may say, one of them use rules, one of them relies on data, and while relying on data, we are developing an algorithm. Again, there is a difference between machine learning and the traditional programming, which could be seen here. If we have the case of traditional programming, our input, I have data, which is just like an input for now. And I have a program, and based on traditional programming, this program, I am going to give you an output. The second example, which is machine learning, which is going to take the output from traditional programming, which what we were thinking is, wow, it's the output of traditional programming. It's just the input for machine learning, okay? Add to that data as input, and we are going to have, instead the typical output, a program, a powerful program, okay? Is this clear? No.
Yeah, that makes sense.
Yeah, it makes sense, but I would illustrate it with an example for sure. I cannot let you. Okay, you can sleep, guys. I don't want you to feel my class is boring, but I want to make sure that everything is clear. Okay, one example that everyone is doing machine learning would tell you. and you're going to tell to everyone later, is the example of, like, if you're having in your email, there is spam and there is the important emails or emails that you receive. Now, how to do this? Just we are going to escape a part and then I'm going to come back, but it's just a simple example. So you are going to have emails. Some of them are okay. Some of them are considered as spam. And at the end, you are going, if you are having a new like email, we will see if it's going to be in your spam section or it's in the main section, okay, of your email. So now, given the traditional machine learning, what will happen here? We are not doing the same task. In machine learning, and given this example, we are using rules. Means me, I have a set of rules that I am applying. However, for machine learning, what will happen is that I'm using training data, which makes the difference. Okay, there is the training for learning. Okay, so for traditional programming here, in traditional programming, you would write a set of rules to classify an email as spam or not spam. For example, let's see. If any email may contain some words like free or win or buy now, and anything like this will make it look like a spam. So it's going to be marked as a spam. You're going to write this as a rule. It's a fact, okay? Then, if the emails come from a certain domain, so you make sure that these guys are all the time annoying you. So it must be like marked as a spam for example. And so the input in this case is the content of the email, which is the words here. The input is the data you are going to see. Here, the input is going to be words, center information, like information related to that email, okay? The program is the set of pre-trained rules that you are going to feed. And each time, like we seen in the loop, you are going to check, maybe you will update your set of rules and so on. And the output is the email is either like a spam or not a spam. So this is the case using the typical or traditional programming. Now, if we see it from a machine learning perspective, in the machine learning approach, instead of writing specific rules, you would feed the system a data set of previously labeled emails, which we see here. So here, these emails are previously labeled. And when I say there is a label, it means there is an additional information about that email. One example of the additional information which is useful in this case, whether it is a spam or not, okay? How to get labeled data, how to label your data itself could take you many weeks. It could be an AI project or machine learning project, okay? Because in data, there is a very hard part, which is cleaning data. First of all, getting data, cleaning data, visualizing data. And there is a whole field of data engineering. So data engineering, it would be taught in different classes, okay? But let's suppose that we have the data. I know I have a set of samples, a given number of emails, on like I have the information or the mark of it's a spam or not a spam. Now the machine learning algorithms learns from this example to automatically classify future emails. It's going to be automatic thanks to the algorithm, thanks to the learning process of the algorithm that it's gathering thanks to the input training data, okay? So the output now from the traditional method, whether an email is spam or not, could serve as an input data. You see the difference between here, we are saying this is output to say each time you have an email spam or not. Now, based on if it's a spam or not, I can learn. So whenever a new email is coming, I can tell you there is a program to classify that, because in this particular case, we are in the context of classification problem. We go through all this like machine learning examples. So the input here is emails with labels, and the output is a model. We call it also a program somehow, but it's really a model. When we are talking about machine learning, deep learning, there is a model architecture, okay? That classify new emails as spam or not spam. So now I believe it's clear. Okay? Okay. Let's see now how to automatically update to the changes. Because if you are having data, your data is not static, which can happen at some scenarios. But given the case, for example, of an autonomous driven car, for example, what is your data in this context? For example, Now we
Well,
are designing a car. Yes?
initially, it's recordings of a human driving, right?
Yes, this is given like, it could be an example. Yeah. The recording of a human driving could have what type of information or data, Jeremy?
What type?
Yeah, because when we talk about data, there is now a different topic to discuss. When we say data, which is a huge topic. So if I'm talking about the recording, it could have different features, which could be
I'm not sure what you mean.
okay, what is the recording? Give me an example. Okay, I am the driver. What could be the driver recording that you may have it?
How they turn, how fast they're going, the kind of
Uh-huh.
road they're on, things like that.
Okay, so in this case, you are going to have, let me say, a vector, could be a matrix of, for example, the feature, like you were saying, how far, I don't know, if I'm playing any music or not, if I'm using any, whatever features, okay? So these are the features, okay? And then for each one, I'm going to have yes or no, an answer, let me say, which is going to be, let's call it, whatever, numerical value, or this is for me, let's say Rania. This is just one sample, means one example. For each sample, you are going to have different recording, okay? So these are the recordings. Okay, we are going to have different, like, people with these, like, having different values and so on. So this is sample one. Sample two, for example, it could be the recording for call. Okay. Here, we are presenting our data as matrix, okay? For different samples, I'm answering to different questions. Now, imagine you are a car, autonomous car. So, what is the similarity? What could be the data that you can, first of all, analyze?
The type of data,
Yes.
it could be images.
Yes. So, if you are a human, you're opening your eyes. So, if I want to make a smart car, it also must open eyes, which are sensors in this case. And the sensor is a camera. And the camera is going to give me images. So, this is the first data type. Would be, I don't know, stored, let me say, CSV file or whatever. Next data type is going to be image data type. And by the way, it's between us. That image is a matrix. And it's having different like numerical values here, which are, Zoya last time was discussing, the RGB values and so on, okay? So, but let's say it's an image, which is having, let's say, different extension, PNG or whatever. So, the image is at each time key, I am going to take a picture of the road, and this picture is later going to be given to the machine learning algorithm. I suppose it's a machine learning algorithm. Otherwise, autonomous cars now are using other types of algorithms. And at each time, I'm having different data. At each time, I'm having different image because at each time, I'm at a different position. So this dynamic of the data, because data is not always static. So this dynamic will make you need to have an up-to-date algorithm. So this is going to be used to update the machine learning algorithm. And each time you are going to update, you are going to evaluate your solution again. And if it's okay, then you are going to keep going. Otherwise, there would be an accident, the car is gone. Algorithm is crashing. Is that clear? Great. Now we are now understanding the importance of this thing. Now the machine learning can help humans as well to learn. And always you have human in the loop now in computer science, because AI is designed to help humans after all. It's not designed to be independent from humans. So, for example, even that those days I'm 60%, let's say, relying on ChatGPT. But as I was saying, ChatGPT, it's not whatever is giving we are using. I said, do not copy paste from ChatGPT to the exam. This is a big mistake that can happen ever. So, okay, use it. I'm making it available for everyone, no worries. But use your brain as well. So as a human, AI or machine learning or whatever is going to give you, based on data, each time new like information. And you must, each time, once you have your solution, you need to inspect the solution. It's not you blindly adapt that. And you need to understand, this must help you to understand the problem better, okay? Okay, the output of GPT, for example, is not the final output. However, it's the step towards the output. If it's not exactly the optimal solution, it's taking you to the way of the optimal solution. And I encourage using ChatGPT, okay? So, and this we will keep doing again and again and again, okay? So, this is even why we use machine learning, because we need it. We need it. It's like, we will see why. And think of it until I will be asking you this question. So, useful when? When it's useful, learning. Instant question. Okay, this learning, this party, I'm coming and you guys are coming and there is a machine learning and everyone now will call you the AI experts. Why we are making the machine learn?
I feel like it's only useful. Oh, sorry, go ahead.
Yeah, sure. Okay, go Zoya and then Farah.
I feel like it's only useful when, as you're getting new data that like fits the same category as your previous data, like it's not random and it's not that the new data is getting worse in quality, because then you're not gonna, like, machine learning won't actually help anyone.
Honestly speaking, Zoya, I didn't listen whatever you are saying after. It's only useful. So if we are asking about the utility, there must be many like use cases. So in short, your possible use case is when?
So I was thinking like you have to be able to have good data that you can apply it later, like
Yes.
it's generalizable, I guess would be the term.
Yes. This is an accurate like example of answer possibility. It's a case scenario of when AI is useful. Any other possibility, yes, Farah?
I said to make better decisions, we learn to make.
Okay, so there is a contradiction between your answer and Zoya's answer, which is, so you are relying, or you are a person who is saying that AI is always, or machine learning is always there to give the optimal solution. But why? We cannot get the optimal solution by ourselves as human. So why, at the time that Zoya is saying it can make mistakes if it's exposed to more data? Okay, it has limitations, Zoya. We are not against. But
we're trying to make it
useful, because if you compare it to a human, it's not the same.
Yeah.
Okay.
It facilitates the tasks to the human.
Great. So this is why we were just saying that it helps human. Yeah. Even if you see the curve here, it's not all the time helping humans. But when it's good, it's helping humans. ChatGPT is not all the time serving you, but most of the time it is. Okay? So when any other answers? When learning is useful. Otherwise, we will say it's useless and I will delete the slide. Learning is useful when? Okay, to help finding an optimal solution, to help getting, let's say, a general rule, or like a final, let's say, model. It's useless. Why it's useful or useless? Only for this reason? See how many reasons. So we are online, so I'm not sure if other students online maybe have problems with like muting or unmuting, so I understand that, or maybe some are just attending, they're in different meetings. So this is the only reason I may ask Jeremy or Zoya. If anyone else is having the possibility to activate his mic, you are most welcome to answer. So I am going to associate these 3 points with the 3 in-person students, okay? You're going just to read each one, try to guess or explain for us, okay? And for Zoya and Jeremy, let's say the last 2 points. So we will just check, like, go through the lack of a human expertise. It's a little bit like similar to, no one is thinking of this point. How you can see this code?
Are you asking me to like rephrase it or?
Not rephrase it. If you are reading this, how you would understand if I'm going to tell you that learning is useful when there is a lack of human expertise?
I don't know if I understand the question. I mean, I guess when there's a lack of human expertise, when I just don't know what to do, then, you know, learning is useful for.
So I know that your expertise it's in mathematics, right?
Yeah.
So let's suppose that I am coming with a problem in the medical field. Are you going to behave with the same answering a problem in maths? For sure, no, because each of us is having his field of expertise. So what we will do now, the AI model, if it's there, let's always think about the GPT because it's there every day and everyone is using. I can ask him if I'm having troubles with cooking, I'm having troubles with what else? Understanding like a medical like stuff. If I want to buy some product, I'm asking him what is this product is made for, like whatever field you feel like he understands everything. So this is an example where AI addresses the lack of human expertise and where the learning is really useful, not only useful, powerful. Okay, now let's move to Zoya, for example. Zoya was discussing about data. So Zoya was mentioning a limitation. She said he's having troubles, and that is true. We are okay with that. But at least as human, for example, I have troubles. I have problems of whenever I'm exposed to a large amount of data to process. Okay? You, for example, as students, you may have problems if you are having 20 classes, you are taking 20 classes and you are going to prepare for 20 exams. I may face some problem if I only think that I'm going to correct 20 copies of exams, okay? So now there are, for example, before I remember last year or before that, I was the only professor who was, I was working in a department when different professors are teaching the same thing. It was deep learning class. And the final exam was just a quiz. You are going just to take the right answer, okay? And I had at that time at least 30 copies of like exam. It's the same questions, but 30 copies. It's really a hard task for me to do. I was wasting, no, I won't say wasting, but if you will listen what other professors do, you will say you are wasting. So it was taking me like 3 days that I need to, it's really confusing. I feel pain at some point. It was really hard task. I was talking with professors. I said, 3 days I'm working with the exam correction. It's taking my energy. Think I did that in 15 minutes. How you did that? There is an app. You just take a picture. It will tell you how many wrong. Like you give the correction. It will tell you how many wrong like answers, how many correct answers, and it's accurate in 99% of the cases. This is an example where there is a technology, machine learning system or something that's detecting object, it's making classification, it's telling you if an accurate example or not. If you compare that to a task performed by a human, and I remember I was teaching more than one class, so imagine hundreds of copies. So it's really hard. Okay, I understand. Zoya, now if I will be coming with billions of exam copies, maybe there would be a problem. But in some specific cases, huge data, it's just a little data, okay? Because it's proportional. Huge data for you is not the same, like huge data for someone else. Okay, Zoya?
Yeah, and that makes a lot more sense of like solutions adapting to its user as well, because I assume that would have to be pretty large, you know, every person's unique.
Yes, great. Now next, who wants to discuss this point? We have, yes?
I was asking the third one.
Yeah, humans can't explain their expertise. To make it clear, I would say only professors must do. Good professors, because there are bad professors, because they cannot do. Okay, machine learning. I know that. What is machine learning? I don't know that, but I'm sure that you know that. How to explain that? You don't know how to do that? No, if you go to the machine learning and you train him given many slides and ask now, give me a short paragraph, what is machine learning? You will get the accurate result. Is that clear? Okay? Another way, yeah, so we have now Ayub and Jeremy are left. First, okay, Ayub. The solution changed along the way in an exceptional way.
This one's from me, right?
Okay.
So my understanding of it would be sort of like if you're, I don't know how familiar people are with playing chess, but after you get into a certain opening, there's like a pattern of memorized moves that most people who play chess seriously just sort of know that they're the best moves. So if two
Great.
people were analyzing this sort of a situation, they would kind of look at minor variations in the best currently known set of opening moves. But if you have access to a much wider range of data, I don't want to say in parallel, but sort of looking at it all at the same time, what you'll find is there are some differences that people wouldn't necessarily look at that can have drastically different results. And it's almost like backtracking a really long way because a very slight difference over in this other corner in this field of moves and situations changes the dynamic of the whole game or changes the situation to say that now all of these moves that you thought were bad over here lead to this situation that is much better for one side or the other instead of this opening that you were thinking of before.
Yes, you are right. So this is also illustrating the same idea here. And thank you so much for this explanation, especially for the example of chess that we are already discussing this before. So I really appreciate it, Jeremy. Now the last one for Ayub is?
So the solution must adapt to its user biometrics filtering email. So I can think about, for example, the personalized ads on Facebook. So everyone gets ads based on
Personalized ads are also known as recommendations. And here we talk about commander systems in AI. You are right. This is also a very good example. Yes?
So the ads can be, everyone can get ads based on his choices and preferences. So it may be the case of this.
So this is why learning is useful. Okay? So we are now going through, let's say, the main important points why learning is useful. So why learning is useful makes it gives the utility for machine learning. Okay? So now, if learning is useful, and this is a fact for all the above reasons, okay? Why now we are discussing machine learning? And when I say now, so means starting from a given year. It's not now like, why it's not coming before AI? Why it's not coming like since like hundreds of years? Why it's coming at a given specific time? And why today we are studying that?
Because now we are exposed to so much data.
Yes, this is the number one. When you are talking about machine learning, you cannot do that without data. This is the key. Okay, yes?
And we have some resources where we can run our.
Yes, so we have the computational resources because if you come back to the time of Einstein and I don't know, the famous, why it's not coming at that time? Because they maybe all they had a paper and a pen. Okay, so now load of available data. That's great. Increasing computational power. Thank you so much. Now, the last 2 points. Who wants to discuss? You can read the last word and guess. If we are talking about researchers. So we are talking about, I would say, a race. And a good thing, if we are doing this race for the good of humanity. This is a very good thing.
Yeah.
Now, for the good of humanity means what? It means we are contributing to the research for like addressing serious problems, and this is really good. So we have tons of available papers now produced by researchers. So this is why most of them, they are doing machine learning. Many papers are in the machine learning context. This is why now we are having more resources when it comes to knowledge. We can even develop more ideas, and this is why we are studying or doing that now, okay? Yes, I would suppose that all existing research is noble, because when it comes to research, there is very good things, but also there is that dark side. The dark side is always there everywhere. Like, for example, someone who's doing PhD, he's considered as a researcher, he is waking up at his last year and he's not having any publications, he's not contributing to the knowledge, and he wants to write a paper. So who would be writing whatever things, and that would be maybe published. I don't know what ways they may use, okay? So let's consider the good side of everything for now. Increasing support for industry. You know what? When we talk about industry, we talk about money. And if we are discussing money, and even you support that now, you are the CEO, are you going to pay any or to fund any useless research? For sure, no. Because if you are going to pay, you want at some point have a guarantee, let's say, that your money is bringing something. So if now we have all this and machine learning is showing its power, and this is why they keep investing, okay? And this is how we can see like OpenAI solutions coming, and this is like explaining everything, okay? So this is why it's coming now. Because before, in the start, for example, if you take the example of deep learning, let's say, deep learning only 5 years back, or 6 years back, okay, 6 years back, deep learning was not like, not like everyone is familiar with deep learning. We will discuss. So it's not everyone is trusting deep learning. So if, let's say, there is a set of PhD students and I am their supervisor, and I am going to give to most of them typical machine learning problems or computer vision problems. What does that mean? The students will be extremely happy because they see that the problem they are going to solve, it's adapted. There is a lot of research, there is a lot of trust, there is a lot of fundings. But if that professor is coming to one student for any reason, he's saying you are going to work on the deep learning project, you will see the other students saying, oh, thank God I'm not getting this project. And what they will be thinking, that student cannot do anything, because at that time, most of the people were hating deep learning. At that time, industry do not want to invest in deep learning, because we will see later it's a black box, okay? So that student would feel the worst feeling ever. So even there is no resource, there is no documentation. If you go tell to everyone I'm doing deep learning, they will say, what is this? So after how many years? 6 years, this person is the happiest, it's me. I was working on deep learning when it was black box, when everyone was like not understanding, but at that point I was saying, oh, this is the problem that they are black box. I will try to make it explainable. Okay, so this is an example. Okay, now, I don't know what is the time.
3:40. 3:40.
Okay, still we have some time. So let's take a moment for brainstorming. Now you are familiar with the definition of AI, or of machine learning, excuse me. So when we say machine learning with this background, what comes to your brain? What fuzzy like things that you are hearing about machine learning that you want to discuss? Or I say machine learning, what you can say, just in 2 words. Cannot give me one sentence, or just 2 words. Machine learning, what your brain would say at this, the first like thinking. This is how we brainstorm. I would say machine learning, what comes to your brain? Just 2 words. I would accept 3. Okay. Ta-da. Check some for the input. I'm bringing some pen. Okay, we don't have much students. I'm bringing many papers, so I'm always optimistic. Okay, so let's try to write machine learning, 2 words, what comes to the brain? Okay, we make the background so it shows. So for the online students, we have how many students online?
Looks like 5 of us. Oh wait, no, 4
Okay,
of
you
us.
can share, if possible, for sure, in the chat. So you can send a message. What words come to your brain if we are discussing or talking about machine learning? Whatever answers we receive, it's okay. If you cannot send anything, don't worry. I don't know. Message here. Mhm. So I'm not talking about the definition, but I would accept if you have more than one suggestion, you can ask for more papers or send more messages. So when they talk about machine learning, and maybe you don't know about machine learning, what are the, or what comes to your brain? If you need more papers, I can provide. Yes. Okay, we have more papers for. So I'll mention the names. Oh, this is from Zoya. Just write your name, and you can get more papers. It would be more nice to have more answers. Making computer smart. More papers. Okay. Papers will there? How many? Two, one, one. Okay. Let's see. Which means most of the answers are coming from the online. Okay. In between, you are taking your break. I don't want to listen. She don't give us break. See, I'm giving you. Yeah, almost. Okay. Now you can take a look on each other's. Okay, I will stay here for the camera. So for the online who cannot see the screen, I will be sharing a picture like we always do. Now we are getting different answers. So if we are brainstorming about machine learning, learning, we are having this set of probably fuzzy like concepts for you. Probably this for you what means machine learning. So let's discuss that because it must bring to the table most important ideas for machine learning. So most of them, we have adaptive computers, Zoya. So if you can give more context or explain more, because I know I'm limiting you with 2 words, but I'm sure you have more to say about this.
Yeah, I was thinking that like compared to typical data where we feed in the rules and the data and that's what it's got, machine learning adapts based on new data and yeah, I think that's just
Okay, so this point is related to data. Okay, so if we have dynamic data, like we were saying, machine learning is adaptive to that data. It depends. If I have a new information coming, there will be a new rule on the spot. It's not like before. If there is no rule, there is an error. Okay, so this is related to data. So now we start making clusters, or when I would say cluster, it means a group. I'm going to regroup things, which like things which are in the same context related to the same topic, I'm going to place them together, okay? So this is related to data, adaptive computers. I can see here, it's clear, big data by Jeremy. So, no, why whenever Jeremy, missing E. So Jeremy, you are talking about big data. This is a good thing. We are already discussing that I can make rules if I have limited search space, for example, limited space. But if my space is huge, I would always say not really huge because Zoya is already introducing why. But let's say it's a big space. Then we can talk about big data. And here where machine learning comes. So Zoya, machine learning comes in the context of big data. Yes. And there is, if we come to data. Now, you can tell me about the size of data that you know? Size. Okay. Words similar to big data that you know?
Sorry.
Data?
Who's this one for?
It's for you.
Oh, I mean, size, like an example of where big data is used or big data applies.
No. When you call big data,
hmm
when?
When?
It's big.
I mean, it is kind of a broad term, but it's the idea that it's big enough that
Yeah.
meaningful patterns come out of it just because of how big it is.
Okay, big enough could be 1,000 samples, 2,000 samples.
Yeah.
Okay, let's talk about 1 billion sample. We talk about a data. You ever heard about concepts like data lake?
Mm-mm.
Data can go bigger than big data, okay? So this is where data engineering comes. So data engineering, it is when we teach data engineering, we teach the simple data structures. Means I'm talking about a stack, I'm talking about queue, for example. Then I will move. I have data about, I introduce the population. In maths, we talk about omega, it's the universe. So my universe sometimes is limited to Flint, then Michigan, then the whole USA, then the whole world. Then we go bigger in the space, okay? So there is unlimited possibility of data. So data, if I'm just considering one autonomous vehicle being driven, I have images. In a day, for example, I have 1 million, let's say, it's not driving much. So, but how many users I have, like how many recordings or samples, he said, Jeremy, I can have billions. If I check not only in the US, and we suppose now we are in a more advanced that everyone is using that. So the data, it's unlimited. It's really like exponential. So you cannot control. And this is why when you are studying data, you are not only limited to simple data. There is a whole field or research study which is conducted on big data. Then we move to data lakes. There are more, even bigger, okay? So this is really a big and huge field, which is related to machine learning. We understand if there is learning, there is data, and we cannot learn from only one sample. I need to show you multiple chairs to say that this is a chair, multiple representation, multiple data. We will see the type of data later. So this is still in the data group, okay? Next, what we have here that you can see is related to data. So Cole, what do you mean by connections?
I just kind of like making connections between different data points and things like that.
Data points means here you are talking about representations. So here also is inside the data group. Let's put it together. So in the data, we have connections, representations. If I can visualize my data, how it's going to look like, what visualization tool I'm going to use. Sometimes you represent your data with, like he said, just points. Sometimes you use a function. Sometimes, what else? Just an expression, and it depends. So this is data, this is data, this is data. And so when it comes to data, I think this is on optimization dynamic, also from Cole.
I was thinking more so like about optimization modeling.
Okay, so you are saying the word modeling. So we will add that to a different cluster. Now, time saving, reinforcement, Okay, so I believe this is all for the data cluster or group. And when it comes to data, we were mentioning, so the data itself, big data, or how to store your data, storage. Have you ever heard about the SQL? Is the very basic one, okay? So here you are having data. It's related to problems. Data collection. Data pre-processing means preparation for your algorithm, because if you have unclean data, we will see what does that mean. For example, you give to some algorithm, the algorithm will get confused. It will not give you the best results. So pre-processing, visualization, and representation. We were talking about how to represent knowledge, for example, and it's a huge field itself, okay? Now, okay, let's suppose that the life is nice and simple and easy and the data is clean, which is the dream of every machine learning or data scientist. So now my data I'm going to give to a model. Okay, so this model is going to be your, let's say, model for now, okay? But we are in the context of machine learning brainstorming, okay? So who is given an example of a model? We have large language models from Zoya, which are LLMs. Okay, LLMs, are they machine learning models? If we have the big circle of AI, so I would say, is machine learning AI? Yes. Is AI machine learning? No, because it's included. So for now, I can say large language models, yes, they are part of the machine learning. But if you dive deeper, what we will see in machine learning, we will deal with data points, with representations, which are like what? Stored like image, for example, recordings, like Jeremy was mentioning. But if we will move to a different thing, which is a text language model, it is. So we talk about language, and language, I can keep talking. You can now check how many words I'm saying. So it's huge. So it's different data. So, okay, we can say this type of model could be seen as a machine learning model, but it's really called large language model. It's mentioned the name, specifying it's related to large language, okay? Which is an application. We can apply machine learning for natural language processing, okay? It may be started from there, okay? We have simple algorithms like the bag of words or something that then lead to the works on LLMs. Now we have other algorithms somewhere. Reinforcement learning. from Germany. You guys are very advanced. You are giving me very advanced things, which makes sense. Because if you are this same question, if I would ask to students 5 years ago, I won't see things like this. Because things like this are today trend. So, okay, machine learning is, let's say, the very old thing as compared to these words. But at the end, we are somehow mapping these concepts. To clear things for every reinforcement learning, it's like large language models. It's a different like case study, like I say deep learning. Why deep learning is not mentioned here? Because machine learning is something, deep learning is something else. But when I say deep learning is machine learning, yes, that's true. Because it's a subfield. And here reinforcement learning, it's within the deep learning, okay? This is why I didn't say when we say AI, machine learning, deep learning, I said there is still in the list. I'm talking about reinforcement learning and LLMs, okay? So now we are having models. I have some, okay, here someone is saying, Ayub is talking about the domain expertise. I think it's related to data as well, because if you have data in the context of medicine, it needs like doctors to tell you if this report is good or not. It's not anyone is going. So it needs people with expertise. So whatever in finance or whatever, whenever you have a machine learning project, first step you do, because I can come and tell you, you are going to do for code the machine learning or AI project in medicine. You will say, what is this? I have no relationship with this field. So never say that, because for every machine learning project, there is a phase which is called the understanding of the field in which you are working. Because an interdisciplinary field, we understand that there is a whole phase in which, in more advanced projects, you may be collaborating with doctors, you may be collaborated with people with expertise in, for example, medicine or whatever. But with your own background, you can still read and understand at least the basic context of that. So for example, if in one of the projects we are going to work on skin cancer, I'm not expecting everyone to know that, but at least if you even ask ChatGPT, you are going to guess what is that, okay? So always give some time to understand the context of your problem. Next, we have things like so we have things related to machine learning definition here. Like machine learning is about making computers smart, okay? Machine learning also is about automated program creation. We don't want the human to be always there, so we want things done by machine in an automated way, like Jamil was mentioning. Now, it's getting, there is a more one cluster is there. Now we have things like optimization. Again, there is an optimization, one from code, one from Farah. And there is here one about robots replacing people, robotics means, and some about time and energy saving. I will put it together. So when we talk about optimization, I am having a problem. There is 1,000 ways to reach to Roma, like they say, but I would go in the shortest way. Okay, so I'm going, like we were discussing, to have an optimization problem. This is all machine learning about. A problem, I want to optimize the solution to come up with the algorithm or the model that is giving me the best way to solve that. So now, optimization is discussed. Optimization dynamic, I think we're also discussing this. And all this leads to time and energy saving, which is proposed by both Farah and Ayub. So, making computers smart and automated program creation, this is the definition of AI. And then what we have, robotics replace people, which is fiction, but it's an application. It's a domain where we apply AI. One of the domains is robotics. So here it's applications of AI. And this is the dream of some people, but you are right, Zoya. So we see lots of advancements, like the example we were watching in the start, that dog. Who still remember his name?
Was it Spot? That was adorable.
Yeah, extra points. Okay, so I think this is here is about optimization part, which is about the algorithm development. So I think now we are clarifying most of the ideas related to machine learning. Now, let's move to discuss now this in more like details. So other than robotics, machine learning could be applied in security, multimedia, NLP like LLMs, computer vision. I believe that wherever your imagination could take you, you can find a machine learning applied there, okay? And then no one is talking about supervised learning, unsupervised learning, things we always listen when we are talking about machine learning. However, thanks to Jeremy, who's talking about the reinforcement learning. Okay, reinforcement learning is an advanced subfield, if some people could see, but also it's a way of learning, okay? We say like it's learning by forcing, okay? Like you don't want to do your homework, but you know that there are points there, so I need to do. If you don't do, there is a penalty. You are going to miss points. So this is how reinforcement learning works, and it's applied in like also a wide range of fields like learning tasks, gaming, and real-time decisions and all. There is two types, or let me say categories of machine learning, which are the unsupervised learning and the supervised learning. So in the unsupervised learning, there is different applications. Supervised learning also has other applications. This is what we are going to see. Start with the supervised learning. What is that? I don't know where I put my phone. Okay, we have time still, right? 2 minutes. Okay, I'll keep this part for the next time because I believe supervised and supervised learning, everyone thinks that they know because it's simple. But if we really want to really do, it's like missing puzzle like pieces. So I will keep this for the last time, okay? Okay, now what I have to do, I have Zoya and who else? I have Alicia, and I'm going to answer these emails. If you have any questions also, let me know, okay? Okay, see you next time.